Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, we're going to be talking about Computex 2024, but you probably have already seen all the specs and all the products, and you probably all know about that. So I'm not going to spend a whole lot of time on that. Instead, I'm going to try to fill in more details about what's going on with these products and Linux integration. What kind of support will be there when these products start to release? Because that, if you're in the Linux camp, that's probably what you want to know, and nobody is talking about it. So I'm here. I also discovered what AI actually stands for. It stands for all in. All in. Yeah, that's a gambling term, meaning that you have pushed all your chips to the center of the table and you have bet everything on the next hand. And I think that's kind of where we are, seriously. I see a lot of parallels between the web bubble of the 90s and, the internet bubble, as it was officially called. But internet was long, long before all of that. It was actually the web that was the bubble. Anyway, let's get started. The first one I want to talk about today is AMD. So let's go rehash what they talked about, and then I'll come back and we'll talk a little bit more about what they're doing for Linux.
Our new Ryzen 9000 CPUs are the world's fastest consumer PC processors, bringing our new Zen 5 core to the AM5 platform with support for the latest I/O and memory technologies, including PCIe 5 and DDR5. I'm happy to show you now our brand new Zen 5 core. Zen 5 is actually the next big step in high-performance CPUs. It's a grounds-up design that's extremely high performance and also incredibly energy efficient. You're going to see Zen 5 everywhere, from supercomputers to data centers and PCs. And when you look at the technology behind this, we have so much new technology. We have a new parallel dual pipeline front end, and what this does is it improves branch prediction accuracy and reduces latency. It also enables us to deliver much more performance for every clock cycle. We also designed Zen 5 with a wider CPU engine and instruction window to run more instructions in parallel for leadership compute throughput and efficiency. As a result, compared to Zen 4, we get double the instruction bandwidth, double the data bandwidth between the cache and floating point unit, and double the AI performance with full AVX 512 throughput. All of this comes together in the product in Ryzen 9000 series, and we're delivering an average of 16% higher IPC across a broad range of application benchmarks and games compared to Zen 4. So now, let me show you the top-of-the-line Ryzen 9 9950X for the very first time. There you go. We have 16 Zen 5 cores, 32 threads, up to 5.67 gigahertz boost, a large 80 megabyte cache at 170 watt TDP. In addition to the top of the stack Ryzen 9950X, we're also announcing the 12, 8, and 6 core versions that will bring the leadership performance of Zen 5 to mainstream price points, and all of these go on sale in July. Our new Ryzen AI series actually is a significant increase in compute and AI performance and sets the bar for what a Copilot PC should do. Thank you, Drew. Here we go. This is Strix. Strix is our next-generation processor for ultra-thin and premium notebooks, and it combines our new Zen 5 CPU, faster RDNA 3.5 graphics, and the new XDNA 2 NPU. And when you look at what we have, it really is all of the best technology on one chip. We have a new NPU that delivers an industry-leading 50 TOPS. We're going to talk about TOPS a lot today, 50 TOPS of compute that can power new AI experiences at very low power. We have our new Zen 5 core that enables all of the compute performance for ultra-thin notebooks. And we have faster RDNA 3.5 graphics that really brings the best-in-class application acceleration, as well as console-level gaming to notebooks. Now, we have a couple of SKUs. The flagship Ryzen 9 HX370 has 12 Zen 5 cores, 24 threads, 36 megabytes of cache, the industry's most integrated NPU, and our latest RDNA graphics. Strix is simply the best mobile CPU. You know, every NPU is actually not the same when it comes to generative AI capabilities. Different NPUs actually support different data types, and that says something about the accuracy and the performance of the devices. So for generative AI, 16-bit floating point data types are great for accuracy, but they actually sacrifice performance. And the current standard for NPUs is actually 8-bit integer data types. They prioritize performance, but they sacrifice accuracy. And what this means is that developers really have a tough choice to make between offering either a more accurate solution or a more performant solution. Now, XDNA2 is the first NPU to support block 16 bit floating point. And what that means is block FP16 actually combines the accuracy of 16-bit data with the performance of 8-bit data. This represents a huge leap forward in AI capability and enables developers to run complex models natively without any quantization steps at full speed. And what that means is with no compromise. And so let me show you what this looks like. When you look at the example, these are 3 images that are generated by the popular Stable Diffusion XL Turbo Gen AI model. We use the same prompt with no quantization or retraining for all 3. And the only difference is actually the data type. So int8 is on the left, which is what most NPUs are using. Block FP16 is in the middle, which is what XDNA2 has. And then FP16 is on the right, which is the more traditional format. And as you can see, the 2 16-bit images look much better with no real differences between the 2. And it is only because our NPU supports that block FP16 that Ryzen AI is capable of generating the significantly better images in the same time that it takes to generate the lower quality int8 images. And this is just an example of why we believe that NPUs with the right data types are the best for the next generation PCs. And this is why we believe that XDNA2 is the best NPU in the industry.
Now the details that I have gleaned from doing a search, both of articles on the web and looking at the actual release notes for the build. And oh my God, that is not a good way to learn about what's going on. Yeah, that's just craziness. What's going on? So work began in April of 2024, as far as I can tell, with integrating these chips with the Linux kernel 6.9. Now the good news is AMD has a fully open source driver, and so I don't know if they've been just making the changes as they go along or what's going on there. But anyway, the window for 6.9 is closed. They're done taking changes on that baseline unless they're patches. They are now working on the 6.10 release, which is currently in release candidate 3 status at the time that I'm making this video. So it is not available for you to download yet, unless you want a daily build of it and become one of the early testers. Just be prepared for lots of crashes when you do that, because you're not on the leading edge or the bleeding edge. You're out even ahead of that. You're out at the pressure wave. So yeah, anything could happen out there. But we do know that it will include support for the AMD Ryzen Granite, which is the desktop processor part, and the Ryzen Strix Point, which is the laptop part, or the AI. More details will follow when we get closer to July. What I need is the actual official 6.10 release, because then we get release notes that actually says, this is what we did. Let's take a look at what Intel announced at Computex for their AI PC.
And as we've launched the Core Ultra with Meteor Lake, it also introduced this next generation of chiplet-based design, and Lunar Lake is the next step forward, and I'm happy to announce it today. And Lunar Lake is a revolutionary design. It's new IP blocks for CPU, GPU, and NPU. It'll power the largest number of next-gen AI PCs in the industry. We already have over 80 designs with 20 OEMs that will start shipping in volume in Q3. I also want to say, particularly here in Taiwan, a special thanks to our friends at TSMC, which were critical to help us with many of the core technologies that were required to make Lunar Lake possible. This is a great example of the collaboration that we see in the foundry industry with Intel and TSMC and enabling new standards like UCIe as well. So let's dig a little bit more into why Lunar Lake is such an important step for the industry, enabling this next generation of thin and light AI PCs. First, it starts with a great CPU. And with that, this is our next generation Lion Cove processor that has significant IPC improvements and delivers that performance while also delivering dramatic power efficiency gains as well. So it's delivering Core Ultra performance at nearly half the power that we had in Meteor Lake, which was already a great chip. The GPU is also a huge step forward. It's based on our next generation Shi-2 IP, and it delivers 50% more graphics performance. And literally, we've taken a discrete graphics card and we've shoved it into this amazing chip called Lunar Lake. Alongside this, we're delivering strong AI compute performance with our enhanced NPU, up to 48 TOPS of performance. And as you heard Satya talk about, our collaboration with Microsoft and Copilot+, and along with 300 other ISVs, incredible software support, more applications than anyone else. Now, some say that the NPU is the only thing that you need. And simply put, that's not true. And now having engaged with hundreds of ISVs, most of them are taking advantage of CPU, GPU, and NPU performance. In fact, our new Shi-2 GPU is an incredible on-device AI performance engine. Only 30% of the ISVs we've engaged with are only using the NPU. The GPU and the CPU in combination deliver extraordinary performance. The GPU, 67 TOPS with our XMS performance, 3.5x the gains over prior generation. And since there's been some talk about this other X Elite chip coming out and its superiority to the x86, I just want to put that to bed right now. Ain't true. Lunar Lake running in our labs today outperforms the X Elite on the CPU, on the GPU, and on AI performance, delivering a stunning 120 TOPS of total platform performance. And it's compatible, so you don't need any of those compatibility issues. This is x86 at its finest. Every enterprise, every customer, every historical driver and capability simply works. This is a no-brainer. Everyone should upgrade. And the final nail in the coffin of this discussion is some say the x86 can't win on power efficiency. Lunar Lake busts this myth as well. This radical new SoC architecture and design delivers unprecedented power efficiency, up to 40% lower SoC performance than Meteor Lake, which was already very good. So simply put, Lunar Lake, the flagship platform for AI PC innovation, bar none. Unmatched combination of performance, compatibility, applications, software enabling, and power efficiency. We are committed to the AI PC. We're going to drive it forward with our ISVs, OEMs, ecosystem partners, and most importantly, we're going to deliver it in volume in the marketplace. We're partnering with our top OEMs to bring forward the power of Core Ultra and Lunar Lake. So building on Meteor Lake and Lunar Lake for mobile, more to come. And Arrow Lake is our next generation product we'll introduce later this year that will enable AI to all PC categories, starting with the desktop in Q4. And in 2025, it just gets better, with Panther Lake. And Panther Lake on Intel 18A will accelerate and scale our position. And I am so excited about this product because this represents the culmination of so much of what we've been working on since I've been back at the company. This is our 5th node in 4 years. In just the next week, we'll be powering on the first chips coming out on this wafer on 18A. 18A brings process leadership back to Intel where it belongs. And it's been a historic space of process technology innovation and product innovation. And rest assured, we're going to have a lot to talk about at Computex 2025 because Panther Lake's going to be coming to life in a powerful way. So look forward to seeing you and all of our partners here for 18A, Panther Lake, and 2025.
Intel began their merges on the Linux kernel for Lunar Lake back in December of 2023. Now, so the Lunar Lake is a lot further along in the code merge department for the kernel. But Lunar Lake is slated for release sometime in Q3 2024, according to Intel. Again, this is public knowledge. This is stuff they've released on their website. Nothing that I know or have learned as part of a non-disclosure. This is all public data that even you can find out about. So yeah, Arrow Lake is slated for release in Q4 2024. Pat Gersingler said that in the video, and it says it again on the website that is the current plan. So there'll be more details to follow as we get closer to the release dates, and as we also close out 610 and begin the work in 611. Because, based on where they're at, I'm thinking they have enough time where they could actually get changes into 611. To finalize those chipsets, I'm thinking. NVidia, now let's go listen to them.
Ladies and gentlemen, this is Blackwell. You see our the computational, the flops, the AI flops for each generation has increased by 1,000 times in 8 years. Moore's law in 8 years is something along the lines of, I don't know, maybe 40, 60. And in the last 8 years, Moore's law has gone a lot less. And so just to compare, even Moore's law at its best of times compared to what Blackwell could do. So the amount of computations is incredible. 1,000 gigawatt hours means that it would take a gigawatt data center. The world doesn't have a gigawatt data center, but if you had a gigawatt data center, it would take a month. If you had a 100 megawatt data center, it would take about a year. And so nobody would, of course, create such a thing, and that's the reason why these large language models, ChatGPT, wasn't possible only 8 years ago. By us driving down increasing the performance, the energy efficient, while keeping and improving energy efficiency along the way, we've now taken, with Blackwell, what used to be 1,000 gigawatt hours to 3. How is it possible that NVIDIA became so big building GPUs? And so there's an impression that this is what a GPU looks like. Now, this is a GPU. This is one of the most advanced GPUs in the world, but this is a gamer GPU. But you and I know that this is what a GPU looks like. This is one GPU.
Jensen Huang spoke for 2 hours about what they were doing with the server side and the hardware platforms and the ability to network. Basically, they sell a DGX, complete end-to-end solution, and you size it up however big you need. Right, so here's the blueprint. How big do you want? So I know that OpenAI, which does ChatGPT, they're looking to try to get funding for a $1 trillion data center. One of the things that NVIDIA didn't talk about is a GPU follow-on to the RTX 4000 series at Computex. So, yeah, we don't know what's going on there. He's not telling us, and probably won't until they're ready to do something. I don't know if he will. He's busy. His focus is diverted to where they can make money. And he has, as a CEO, he has a fiduciary responsibility to the shareholders and the company to maximize revenue and therefore maximize profit. That is his job. If he fails in that job, they replace him. That's just the way it works, guys. That's how it works. You either make money or you go away. And there are no history majors that remember what you did 10 years ago or a year ago. So work is underway on right now on the open source NVIDIA driver. And there's also work that NVIDIA is doing on the proprietary NVIDIA driver for Linux. Now, there is NVIDIA code in the open source driver, but they also still publish a full support proprietary driver because you need that if you're doing CUDA. At least that's been my experience. I don't have much luck getting the open source one to work with CUDA. It kind of blew up in my face if I try to use that. So I went to the proprietary driver, and it seems to like that a whole lot better. But what's going on? What are they doing? If there's no new graphics, what are they doing over there? Well, as it turns out, they're working on Wayland. They're adding enhancements to support additional Wayland features that they need to get in, like sync, for example. They need that. There was also, in the proprietary, there was also a bunch of bugs that slipped by and got into the 550 driver back in the middle of May. I saw that. Man, it's been a long time since I've seen a kernel crash. But yeah, it happened. I was running along and all of a sudden, bye, black screen. There you go, reboot. So, and that's what happens when you have a driver crash, because there's nothing to hold it back. I mean, if you crash the kernel, you're gone. You might get a message that comes up and says, yeah, we're rebooting, or probably not. Because, yeah, most of the time when the kernel panics, you're done. There was a lot of that. There was also some kernel segment problems that were going on where the parts of it were just blowing up. So, yeah, not good. So there's been some bug fixes they've been working on as well. The current NVIDIA proprietary driver is 555. That's .52.04. That's currently marked as beta. So if you want to try that, just remember beta doesn't it is feature complete usually. Although people seem to be stretching that lately, beta is supposed to be feature complete. That is, all of the things that I had planned for this release are in. I just haven't gotten around to testing everything yet. So that's what's going on with NVIDIA, and that's all I know. So let's go take a look at and see what Snapdragon is doing with Qualcomm. And we'll listen to his presentation at Computex and see if we can learn anything new from him.
So let's start with the presentation. And the PC is truly reborn. It's a new era for the PC. And that is happening with the combination of Snapdragon X Elite and Copilot Plus. We're really making history together, and the industry is actually taking notice. The Snapdragon X series and the Copilot Plus, it's one of the most significant transitions in Windows. Personally, I believe it's as significant as Windows 95. It is changing the experience, delivering groundbreaking AI capabilities, fundamentally changing how we interact with our PCs. And really, the industry is not only taking notice, but consumers are starting to take notice right now, because the personal computing experience is being redefined. Users are now really pushing the boundaries of what's possible across productivity, creativity, entertainment. And what's interesting is Snapdragon X and Copilot Plus are the only platforms capable of unlocking the full potential of next generation AI, not only applications, but how we interact with our PC. And that's what we see that today. I think the whole industry is changing based on what Snapdragon X Elite and the Copilot Plus can do. To the point that now the overall tendency is saying, many companies are saying, I'm going to have this too, because this is such a profound change. And it's all about delivering this whole new experience with multiple days of battery life, unparalleled performance, and the efficiency to accelerate productivity and creativity with pervasive AI. And this is happening in a broad way. That's what I say it's a big change. No wonder, I think we have here on stage those incredible devices. I have been in awe by the number of devices they've all been launching simultaneously with Copilot+, all powered by the Snapdragon X Elite. But the Snapdragon X Elite is a platform that had actually been built for the new generation. We used to call it the next generation PC, but now it is the new generation PCs that are here right now. There's more. Snapdragon X and Copilot Plus are coming to all PC form factors. Qualcomm is now in this neighborhood to stay. We're not going anywhere, and we're very happy to be working with our partners in all the different form factors for the industry. And this is incredibly exciting because PC is truly reborn, and that's a great transition, which is we're restoring performance leadership to the Windows ecosystem. So if you step back, the Snapdragon X Elite and the Copilot Plus really establishes overall industry leadership in personal computing. And within that process, you see not only the innovation and performance leadership clearly now belongs in the Windows ecosystems, with completely new AI capabilities, completely new experiences, and basically it becomes the platform where innovation is happening.
So Cristian Armand talked a lot about he did provide some additional detail on the capabilities of the chip, and their website now also has details about the specs of the different CPU SKUs, and there are 4 in the Snapdragon X Elite, and there's 1 in the Snapdragon X Plus. So what did we learn about Qualcomm after the fact? So Qualcomm did their presentation, and ARM also presented at Computex. And I didn't hear any of the PC people follow ARM at all. They're all listening to what Qualcomm has to say, but if they'd gone over to ARM, they would have learned a little bit more about the Snapdragon, and I did.
If we go back in time to 1981 and just look at the volume that has been driven across computing over these last 40 years, it's stunning. You see the legacy PC, you see ARM, and you see a number that's kind of hard to even fathom. ARM, with our partners, have shipped more CPUs not only than legacy PC or open source, but I would dare say if you combine every computer architecture ever invented and you add them up, they're not in the same order of magnitude as ARM. And that says, do we actually have enough energy to drive all this computing? Now, we have seen some amazing innovation around AI just recently, whether it's generative AI around large language models, whether it's around small language models, training, inference, et cetera. We're in this interesting dilemma where the better the processors get, the more it begets computing, the more it needs more energy, the more it begets computing, et cetera, et cetera. And there are a lot of questions whether there is actually enough energy to drive all this demand. This is a projected US data center energy demand to the end of the decade. And if you look at these numbers, roughly speaking, the expectation or projection is that 20% of the US energy grid will be data centers by the end of the decade. Now that is both exciting and impossible at the same time. There is no way that this can continue without some level of change to take place. And we announced a pretty cool product called the Surface RT. Don't know how many folks remember that product. I know Bob O'Donnell remembers that product because I remember he was grilling me in terms of all the software it didn't run. But he liked the hardware. The hardware was great. We had a Tegra 3 processor, very, very low power. It was also very, very efficient in terms of battery life. The hardware was great. So why didn't this product fly off the shelves? There were no Windows applications that were native to ARM. What a difference 10 years or 12 years makes. Now, the number of native applications that run on ARM for Windows are pervasive, popular, extensive, whatever word that you want to use. All the developer tools are there. So essentially, there's really nothing that you can't do on a Windows on ARM PC. And now, with this modern AI PC, every application you care about runs on Windows on ARM.
We're also excited that CSS for Client extends to the AI PC. We've talked about the performance gains in X925, but it also pairs with A725, which is our efficiency core, allowing for a next-generation heterogeneous computing environment, where you can have the performance when you need it, and yet the efficiency and multi-day battery life that you really desire. This is a foundation for the next generation of AI PCs, and it's built on V9. V9 has brought some amazing security and platform enhancements to Android, such as MTE, BTI, and PAC. Those same capabilities are going to come to AI PC, as well as SVE2 enablement with Kleidi, as Renee so well highlighted.
They didn't elaborate too much. ARM didn't, because they don't talk for their vendors, of course. That's a good way to get into trouble. Here's some information that you didn't know that they didn't want to tell you. No, they didn't do that. They just said that this is what it's about. But one thing that I learned from listening to ARM is they are actually now making chips. They're in the chip manufacturing business. So I think they're using TSMC for their fab. I will find out. I have a big list of things that I need to go find out more about. So one of the other things is Tuxedo, a maker of laptops for Linux. They announced on the 10th of June that they will be releasing a Snapdragon X Elite laptop. They think somewhere around Q4 2024. They said, well, we'll probably have this out in time for Christmas. But again, that's going to depend upon what happens with the Linux support, right, with the kernel support. Because they're not, that company is very conservative. We know that the Tuxedo, because they told us, will have a 12 core. It also has a 2560 by 1600 display. That'll be in a 14-inch monitor. I don't know what kind it is. We don't know if it's OLED or what. It'll have 32 gig of LPDDR5X memory, and it'll have a PCIe 4 slot for an NVMe drive. Now, I imagine you'll be able to get certain offerings from them, but we don't know what those are yet. And we'll find out as it gets closer to release and they start publishing the thing to order. So in the meantime, they kind of hold things to the vest. That's what you do. You don't want to tell your competition everything you're doing, right? So I guess in parting, what did we find out? Well, we found out a little bit, but not enough that makes me happy. So I will keep on this for you, and I will come back and do periodic updates like I did before, kind of let you know what I've learned along the way. So yeah, in Linux, you kind of have to learn to be patient. The wheels turn slowly sometimes, and sometimes they turn fast. It just depends on how many bucks are chasing after it, how badly somebody wants it. So anyway, I'll jump off my soapbox, and I hope to see you in the next video. Please like and subscribe, and again, hope to see you in the next video. Bye for now.